Pandey sir, who has given us opportunity to arrange this online FDP program on additive manufacturing and 3D printing. We have gathered here to enhance our knowledge values from the different experts. Now, today's further, there is a short inauguration program, and for that inauguration program, we have a one chief guest, that is Mr. Dhananjay Jakri, who is a giant in manufacturing and prototype in Nashik. Before going to start inaugurations, I am giving a just brief introduction about that our chief guest. Mr. Jakri is completed his graduations in engineering from the COEP at the batch 1985. He first of all he's worked with Myco for the 12 years in quality and production departments. Later on, he started his own enterprises in the field of tool room, die making, and injection plastic mold. So I'm hand over to our chief guest, Mr. Dhananjay Jakri, to say some few words about the inaugurations and declare the opening of that program. Thank you, Mr. Jakri, sir. Please on your mic.
Yes. Good morning. Namaskar, everybody.
Good morning.
Uh,
Good morning,
Good
sir.
I
morning,
hope
sir.
good morning, everybody. आजचा मराठी भाषा दिन आहे त्यामुळे जरा सुरुवात थोडीशी एक वाक्याने मराठीतनं करतो आणि मग आपल्या मेन टॉपिककडे वळतो. तर anyway, the topic that you have selected is really a wonderful, which is really a need of the time. And I thank you, Dr. Shraddha Madam, and the management, everyone, for inviting me here to be an inaugural guest. Coming to 3D programming, 3D printing, basically this technology now, as I would say that this inaugural talk is rather has to be as short as possible because you all would be awaiting the marathon run to start, and so you are just awaiting a green signal for your day long sessions for 3 days. So I'm going to keep my talk as short as possible so that you can get into the subject as early as possible. So the 3D printing, this basically there are different names for the same technology. Like the way 30 years, 35 years ago it was developed, it was called RPT, a rapid prototyping, 3D printing, and the layer by layer manufacturing technique. So, in all, though the names are different, the technology remains the same. So the technology has roots around 30, 35 years old, and that time it was practically used only for the rapid prototyping of a new product. If the design is conceived and if one wants to have a look over his own design in physical way, then that was really a great help, a great important tool. So, in manufacturing, as you all are aware, there are basically two types. Number one is the conventional one, which we call subtractive manufacturing, and number two is additive manufacturing, and that is this 3D printing or the RPT. So, additive manufacturing is practically a boon to the designers. But of course, I just want to mention here, though the technology is, I would not say it's pretty old, but not even the recent one. Of course, the developments are taking place in this technology. One point I would really like to bring to your attention is like in the year 1996, we have had one such machine here in industrial estate with data switchgear, and it was really something miraculous, which one really cannot, rather would not have imagined that you have this kind of avenues to make the parts pretty fast, because that time the technology was in a green stage, and in early days of this technology we have had an opportunity to use it. Now, what is 3D printing? The 3D printing, I think you all guys are knowing, it is basically the manufacturing based on the 3D model. So far, in subtractive manufacturing also, the manufacturing is based on 3D model. But here, the difference is like you make the parts or the any engineering item, the way you want in a layer by layer, adding the material on the base. Whereas in subtractive manufacturing, you have a raw material maybe weighing 10 kilograms and you cut it down to 1 kilogram. And normally in aerospace industry, it's very common that we take a raw material which weighs around 130 kg and the finished part is just weighing around 2 kilograms. So the important point there is the homogeneity of the part, and that is why this kind of subtractive manufacturing, which used to consume a hell of a material, has been rather substituted by uh, uh, additive manufacturing. So practically, it is a great help for a designer, for product designer, product design moderator, and the marketing people as to how the product will look like when I launch the product in the market. So, in all, as these are the basics of the 3D printing, and since you are going to have a great sessions ahead for 3 days, I would just like to mention a couple of important parameters, important points in this 3D printing. Number one, it has got tremendous flexibility, like the part size, and moreover, even if you have a lightweight part, you can produce it with this technology. Then number two is the very fast processing. Like for any designer, it's very important that how much time does it take for him to roll out the product from the point of conceiving the design. Once the design is conceived, then rolling it out in physical way is always, or rather has always been a challenge. Here, the 3D technology, 3D printing technology has really come to the rescue of the designer. And so it has a very short product design turnaround cycle time. Number three is that it can save a great deal of raw materials. And number four is that very important for mankind is that it can be used in healthcare. It can be used as an implants. It can even directly replace. I mean, the organs of the human body can be replaced, which are manufactured by 3D printing technology, and that is the most important benefit of this technology. When it comes to the negative side or the difficulties of the product produced by this way is number one, that technically which has still not been totally resolved is the homogeneity of the part, or it can be called isotropy of the part, soundness of the part. As you know, this process is a layer by layer by layer. And so there are three important parameters. Number one is your injection of the material, the impregnation of the material, or number two, the different cooling rates, and number three is the joining of one layer to another. So this is typically a issue of isotropy. Due to the difference in cooling rates of the every layer, the layer beneath and the layer coming on the top, there is always a differential solidification that takes place during the cooling of these parts. And that is the reason the isotropy of such parts is always at question. Of course, the scientists are working on this technology and improve its isotropy of the 3D printed parts, but still there is no 100% success on this isotropy. Now, when we come to the materials, you have that way wide material scope, but still I would say polypropylene, because polypropylene is the very useful engineering plastic, and that cannot be. Hello, hello, are you able to hear?
Yes, yes, yes.
Okay, fine. Because I get the signal here, your internet connection is low. That is why I asked you. Okay, if you are able to hear me, that's fine. I continue further for a couple of minutes. Polypropylene is the most versatile engineering plastic, but there is no success so far on developing this material for 3D printing. Rest of the materials like ABS is the most common material used. Polycarbonate is the material that is used. PET, polyethylene tetraphthalate, is also used. HIPS, and most importantly the nylon PS6. These materials are well proven for the 3D printing. But of course, the the properties of these polymers resins are different for 3D printing technology compared to any other process like injection molding or a blow molding or an extrusion. But of course, one really gets a good idea of the parts produced in this way for its form and fitment. Normally, in design engineering, there is a 3F concept: form, fit, and finish. So, with this 3D printing technology, we can ensure a form and a fitting. Whereas finish, we really don't have any choices of material colors and the process. Like you have some RA value for the finish, you have some spark finish, and this kind of finishes on your final product cannot be achieved in the 3D printing process. And so these are still limitations, but of course form and fitment can be well carried out. Now, when we come to the materials in metallic form, we have the option of the titanium, which is mainly used here due to its half approximate half a density of steel, and then we have the option of stainless steel too. Now, titanium, if you look at, it has tremendous versatility as regards healthcare industry and the aerospace industry. In healthcare, titanium is the material which is accepted by human body, though as a foreign material, as an implant. And that is why titanium is more often used material for implants or any kind of thing which goes into the body, like the crowns for the dental application, the implant for the dental application, and even in case of some organs that are to be replaced, the titanium is used. So, with this, there are limitations of material also. The aluminum is also a grade, but which is in development still because of its low temperature processing and the very high affinity to oxygen, which causes a continuous oxidation of any part, any layer formed with aluminum. So I think in general, in short, if I had to be, I have covered the basics of 3D printing, what technology is, then its pros and cons, and the materials that we use. And I think you will have great sessions on all such topics in the coming 3 days. I think I have to close on my inaugural speech and hand over further to the convener.
Thank you. Very, very thank you, Zakri sirs. I hope we all of us pursue the valuable knowledge from all the experts in coming 3 days of the sessions. Now I hand over to my mic, my departmental colleague, Mr. Sadgir sir, who will continue the next sessions.
नहीं सर बोलते हैं ना फक्त इधर
कान बधीर झाले ना त्याने हेडफोन घालून